Prachi Gupta. Welcome to today's COVID Bulletin. Random pooling of test samples has been hailed as an option to study community transmission of the COVID-19 infection, as it requires fewer resources. However, current guidelines by the ICMR only allows pool testing in areas where the prevalence of infection is less than 5%. Now, researchers from three premier research institutes, DBT's Bengaluru-based Institute for Stem Cell Science and Regenerative Medicine, or INSTEM, TIFF's National Center for Biological Sciences, and IIT Mumbai, are working to find a smart pooling methodology through which pooling strategy can be used in high prevalence zones too. They're trying to develop algorithms for the method known as combinatorial tapestry pooling, where individual samples are pooled together with various combinations. Thus, each pool comprises a combination of different individual samples. No two pools are identical. This is designed and achieved using sophisticated computerized algorithms, which are currently being designed by the team of researchers. Once developed, it can be executed by individuals trained in sampling and running diagnostic RT-PCR-based assays using automated approaches. The major advantage of this effort is that depending on the combination of pools in the matrix, it is even possible to identify individual samples that are positive, thereby eliminating the requirement of second-round testing of individual samples in pools and thus providing for faster reporting. Let's hear more on this from the experts.
This algorithm does is it helps you to pool the patient samples in a smart way. So by pooling the samples in a smart way, by using this algorithm, you can reduce the usage of both reagents, and also you can minimize the time that takes in order to report these samples out, right? So that's what it is helping. It is helping more in the terms of diagnostics rather than in terms of building a drug or a vaccine, right? So, and which is very critical in the current scenario. It's the need of the hour currently, right? So that is what we have validated by using a cohort of samples. So what we have done is the Blix Center, which is represented by NCBS INSTEM, was officially authorized to do COVID testing. So we receive patient samples and we actually do the testing here. So we have done around, say, 22,000 tests so far in Karnataka. And what we have done is we have taken different sample volumes. We have taken sample size of 100, 300, 500, and 1,000. And we have set up at different prevalence rates. And we have tested how well the algorithm works. So it appears that the algorithm works beautiful. And now it's the time we feel that we need to implement it in the other centers and see how it goes ahead, right? So that's where we stand.
Ventilation in the COVID-19 testing areas and hospitals remains a prime concern, as the infection can spread from patients to medical staff. To solve this issue, scientists from IIT Ropar have developed negative pressure cabins. These negative pressure cabins ensure that released airborne contaminants do not stay suspended or leak outside and are instead scavenged through the ventilation system. This system comprises a sealed plastic canopy, a removable door around the bed of the patient, and the suction-type ventilation system appropriately placed to maintain the negative pressure and efficient removal of the airborne contaminants. Together with ANSYS software, IIT Ropar is now installing these cabins in the government medical centers in Roopnagar district of Punjab. These cabinets will cut down the risk of a spread of infection in frontline health workers. Let's hear more on this from Dr. Dheeraj K. Mahajan, Associate Professor, Department of Mechanical Engineering, IIT Ropar.
Cabins are currently being installed at Ropar, which is where IIT Ropar is located. So these cabins are basically, we are specially designing this cabin, like making this polythene curtain specially designed, and the room size that we are keeping is 6.5 feet by 6.5 feet, and height is also 6.5 feet, such that a patient, and as well as for if the doctor has to come inside this cabin to examine the patient, he finds sufficient room to examine the patient. And then so these specially designed negative pressure cabins are being installed in Ropar with the support of a software company called ANSYS, which is the biggest software company, with whom we actually designed through simulation based. We designed these negative pressure rooms, and the same design we are using to implement in these cabins. So ANSYS Private Limited, or ANSYS Inclusion, so they have sponsored around 100 negative pressure cabins, and each negative pressure cabin cost around 8,000 rupees, which I feel once it is installed at Ropert, we will be sending the pictures and releasing the videos how it is function, and we are going to make a kit which can be sent anywhere, where even the nurses can assemble it and generate make these kind of cabins around the patient.
The rising tally of COVID-19 patients in the country is creating a shortage of both manpower and hospital infrastructure. To sail through this challenge, two CSIR's research institutes, Roorkee-based Central Building Research Institute and Bhopal-based Advanced Material and Processes Research Institute, have developed a technology to set up makeshift hospitals. Through this technology, the makeshift hospitals, which are resilient to rain, fire or storm, can be erected in just 48 hours. These makeshift buildings will utilize lightweight structures which are foldable, easy to erect, safe, reusable and cost-effective. The institutes have now transferred the technical know-how to Janta Tent and Events Company so that this knowledge can be used to build makeshift hospitals across the country. That is all for today. We will be back with another edition of COVID-19 Bulletin soon. Namaskar.